Okay, so we've just gone live into Second Life as well, and they're seeing like the video stream there, and there's sound as well if they put on their speakers and everything. So maybe if people in Second Life can tell me if you can hear me, that would be great. And until then, I'll just get started. My name is Henrik, and I work at something called the Stanford Humanities Lab. And we do research in virtual worlds, and we're very, very thrilled to see all of you here. This was really like a selfish need of mine to identify people who work in this area, and to meet people I thought was cool. So it's pretty. That was basically the idea of the meetup. I'm also putting together a conference on virtual worlds called the Metaverse U, and that's going to be on February 16th and 17th of 2008. So. For those of you with a calendar out there, please make a note of that. This is our first time, so we are still figuring out what the format is here. So we were thinking about, I was really curious to hear like what you had to say as well, and certainly what Mike has to say, but he was like the attraction to pull you in here as well. So so we're going to try like with an open mic session. If anyone has like, you want to pitch like a project, you want to pitch yourself, you want to pitch an event, come up with ideas for future speakers, topics that you would like covered here, like open mic where you're going to get like a minute's time and then I'll come tackle you. But something like that, and we're not really sure whether this is going to work, so we're just going to do it if people actually come up to me during like one of the designated breaks and say, I would actually like to do this, because if there's no one there, then I'm just going to do some tap dance. And yeah, we feel this is pretty brave, because here in academia, once you give a guy a mic, then you're never getting it back. So so this is a first for us. So we're streaming live into Second Life. And we're really hoping that they want to be a part of this conversation as well. So they're hearing me speak right now, and Mike has got his thing on. So if you don't have this or this in front of your mouth, then please wait, because otherwise you're sort of taking them out of the loop. And we're also trying to record what we're doing here tonight, and we'll make it available. Excuse me. We'll make it available for free on the web afterwards. So please, let's use the mic. And should someone forget, then we'll try and repeat the question. You know the drill. And that's basically why we're here. The Second Life spot here is hosted by the International Spaceflight Museum, which, if you don't know it, is one of the really, really cool parts of Second Life. Totally a bottom-up endeavor that just really is challenging the notion of what a museum can be. It's really cool, and I would encourage everyone to check it out. Kat from the International Spaceflight Museum has generously offered to host the in-world viewing party, so we just kind of give her a stream. She built this whole thing for the event, and it's pretty nice, and definitely a new stab at what such a meeting room might look like. Which, these things, like that's what virtual worlds are for. That's for reinventing all this stuff. So that's very cool. Sorry.
The International Space Flight Museum should be available and visitable anytime, right?
Yeah, which it is. It's there all the time, and it's free and open for everyone to see. If you Google International Spaceflight Museum, then I believe their website comes up, and then they'll tell you how to find it in Second Life. And if you haven't yet, check it out. It's gorgeous. Thank you so much to them. And so I'm from the Stanford Humanities Lab. We're putting this thing on, and we've also received some kind help from the folks from MediaX, Chuck and Martha, and we're very appreciative of that, and we'll be looking forward to future events with you guys. So let's get down to business. So we invited Mike to come here tonight, and he gracefully accepted. I figured out, along the lines of getting interested in virtual worlds, coming to this from games, that actually these virtual worlds were more than these magic circles, that they were enormously leaky, and they had everything to do with my life and with the rest of the world. Of course, someone like Mike knew that all along, because he's been thinking really hard and smart about this stuff for many years now. So I'm actually thrilled that you wanted to come here tonight and talk about it, so thank you so much. Mike, the great thing about living in the Bay Area is that you can shoot a guy like Mike an email and say, hey, you want to go have lunch? And then the guy actually says yes. So we go for Indian food, like the first time we met, like right down here in Palo Alto, and you know, this is a guy with a pretty good-looking CV, and he's worked everywhere, and he can kind of make you feel like the guy who never left your mom's basement. And but he's totally open and so eager and passionate to share his knowledge that I just made a mental note. You know, this could be an opener for this thing I'm trying to do. And so we spent this lunch geeking out, and I just knew there was a lot to learn. So I hope that you learn a lot from Mike tonight as well. And thank you so much, and take it away.
Thank you. Hello, Second Lifers. Can you hear me? Okay. I'm really, truly delighted to be here. And as I mentioned, I have been investigating aspects of the topics I'm going to discuss for a long time. I actually started my career at Atari Research in 1980, and we had people in those days who were thinking about virtual worlds and 3D graphics. There was a whole gang of people from a group called the Architecture Machine, which was the MIT predecessor to the Media Lab. And so a lot of the concepts we think are new are already 30 years old. And even though the title of my talk is 3D data for real worlds and virtual worlds, I'm really going to talk about the interoperability between virtual worlds, which exist as kind of standalone walled gardens, lots of them. And I'm also going to talk really about the blending of the real world and virtual worlds. You know, there's a lot of things existing simultaneously in the digital world these days, and the key simultaneous developments that I'm going to talk about are the geospatial web, virtual worlds, and augmented reality. And they all fold together. And so we'll just kind of review some of those topics. This is a kind of a once-over lightly of some topics that I'm looking at rather deeply. In fact, where I work at a group called the Institute for the Future in downtown Palo Alto, our research agenda for the coming year is blended realities. So this is a hint at some of the topics we're investigated, and there's actually a lot more that we could talk about here, but I'll kind of give you a tour of some of the background information that we've developed. So one of the first important things to think about is cubic cartography. Most people think about mapping as two-dimensional, but for a lot of reasons in both cartography, geospatial computing, and in virtual worlds, there's a convergence around the idea of modeling 3-space and rendering information in all the dimensions. This, of course, brings in new problems. Part of the problems in the 2D world have been solved. We now have a really fantastic framework for a two-dimensional geospatial web based on something called GeoRSS. It's just a simple semantic for describing latitude and longitude in any hypermedia object, web page, video. It's just an extension of RSS. But you can put the location of an RSS feed on a map. And so this is a grassroots, bottom-up standard that was developed, and within a year of development, Google, Microsoft, and Yahoo have all embraced GeoRSS, and all of the big guys on the mapping side have also embraced GeoRSS. So that means that you can create a hypermedia object, a web page, a video, a graphic, a PDF, and assign it to a location, and you can view that link, that annotation, that place mark, independent of the viewing software. You can view it on a Google map, you can view it on a Yahoo map, a Microsoft map, an Esri map. Does not make any difference. So this is a big, big start. So we have now, for this blended reality of virtual worlds and real worlds, we at least have the starting place of a two-dimensional framework. But when we get into 3D, we have just all kinds of new problems. We have things like points of view, geometry, lighting, physics. The volumes is easy to describe a volume in XYZ coordinate space, but describing all of these other things require a new kind of thinking. These are models of reality, and so even though where there's an ability to exchange even three-dimensional coordinates for objects, getting all of the behavioral details is very, very tricky. And so there is, in fact, a lot of work that we all have to do to really realize an interoperable 3D web that allows people to have some common understanding of points of view, geometry, lighting, physics, and behaviors of actors and avatars and so forth. So one of the goals is to have a capability to mix interdisciplinary knowledge. We want to be able to blend not only all of the imaginary worlds, but there's a lot of real worlds that want to be blended in 3 space. Environmental information, meteorology, oceanography, biological information, geology, plate tectonics. These are all the kinds of things that are moving towards co-rendering environments, co-rendered environments. This is a demonstration project that was done at UCAR, University Corporation for Atmospheric Research, called the Everything Globe. It's not really everything, but it's a lot of stuff in one place. Part of the problem, as I kind of hinted at when I was talking about points of view and physics and behaviors, is that there's a great deal of semantic load to all of this. And so there are projects in the National Science Foundation, for example, to ensure that, that three-dimensional data and sensor data that was created by, for example, interdisciplinary life sciences and environmental sciences can be rendered in common three-dimensional spaces. So we're moving ahead on the professional side and on the academic side. And so we're moving in science from thinking about these two-dimensional maps to three-dimensional renderings of sensor information. And there's lots and lots of examples of this stuff in oceanography, in meteorology, and in fact, there's even people who've created three-dimensional maps of signal strength of Wi-Fi. Just imagine you had some magic glasses on and you could see the Wi-Fi signal strength in the room as blue and yellow and green clouds, and you can see different networks. In the future, it's all going to be possible. You know, in fact, one of the thought exercises I like to do is I walk around and I pretend that I can see the invisible information in a place. I pretend that I can see signals. I pretend I can see mathematical probabilities of things happening. I pretend that I can see all the attributes. I pretend I can see the conduits behind the wall. It's, you know, it's a fun thought exercise, but all of it's going to be possible. There's a lot of converging trends that are going to enable us to see invisible information. So we have fields like bathymetry and other geospatial disciplines that need to build these kind of platforms for three-dimensional data. So in the end, people are going to want to build really rich models, simulations on a coherent, real-world virtual world. And there's a lot of industrial models that might be built as well as a lot of natural models. So we're seeing a shift in our perception of reality based on these computer graphic three-dimensional spaces. One of the interesting things that's happened is in the fields of navigation, up until very, very recently, the maps that we used for navigation have been 2D maps. And there's a little bit of cognitive dissonance that I experience, and maybe you do and other users do, is that a map is a view from above, from an aerial view or an airplane view. It doesn't correspond with the way we see the world. So there's a new kind of geography and a new kind of cartography. It's a first-person cartography. It's a cinematic view. And I didn't put the slide in here, but it's really interesting to note that there's a group at MIT who did something in 1977 called the Aspen Movie Map, which built a prototype of this user face identically, and it only took 30 years to get it from the lab to get it out into the real world. So it just goes to show you that sometimes it takes a long time to get really cool new ideas out of the labs into the real world. So there's an arms race in creating real world 3D data. This is a picture of a TeleAtlas truck, and they've got some smaller vans they drive around. Both TeleAtlas and their competitors, Navtech, have been in the news lately because they've both been targets of acquisition by bigger companies. The way these trucks works is they drive around, and not only do they gather ground truth. Ground truth is, by the way, a term of art for the kind of information you might see on a satellite image, but it's verifying it on the ground. So they create ground truth for maps, and they'll drive around and they'll verify that a street on the map is where the map says it is. And they're also gathering traffic heuristics, and nowadays all of these trucks have cameras pointing all directions, and some of them are equipped with something called LiDAR, which is a sensor device that can spin around and gather three-dimensional models. And so this is the kind of model that, that TeleAtlas is beginning to gather for cities of Europe. In fact, similar LiDAR techniques were used by all of the entrants in the DARPA Grand Challenge, including the Stanford vehicle and the Carnegie Mellon vehicle. All of them are running these LiDAR sensors to get a sense of the position based on the internal model, the three-dimensional map that they carry in the vehicle. So this is very, very important. The interesting news is that Google also now has a fleet of some 300 vehicles driving around gathering this imagery. And so we're seeing another arms race between Google and Microsoft. And there's an interesting difference in the approaches that Google and Microsoft are taking in gathering this real world, virtual world. Microsoft is using LiDAR, but they're flying aircraft over cities. And so what you see in the right-hand side is San Francisco almost as a texture. These buildings are not individual objects. They're a continuous image. Where Google 3D images are all built one at a time using SketchUp tools, and they're stored as collada files. And so I think computationally, I think a lot of people find this model a lot more interesting because you can do a lot more with this one. Google is also doing something that has achieved quite a bit of notoriety, this notion of Street View. Now there's something going on with Street View that is not obvious and is not very well known to people. The fact is that the KML code in the KML 3.3 version, or 3.0 version, which is not the release version, which is the next version of KML, includes with it language to describe a point of view. So you can describe the view angle of the viewer, and you can describe in KML the coordinates of these corners of the picture. And so that means that using the KML markup, you can put place marks or annotations right on the image. So this is the beginning of a 3D GeoWeb. And Google's already there. And KML, by the way, has been released by Google into the Open Geospatial Consortium as an open standard. And I'm sorry to say that there has not been a lot of dialogue in the committees that are working on a public version of KML with people from some of the metaverse and some of the ordinary 3D graphics communities. It's mainly mappers talking to mappers. And so anybody who's interested in getting your voice in on standardizing KML, now's the time to do it, and see me afterwards, and I can put you in touch with some of the groups that are working on this. I think it's very, very important, since KML is really a very important candidate for being a standard framework for real world virtual worlds. So these 3D models that we can create are opening up the idea of new applications like virtual travel. And so you can not only create a 3D model of a place, but you can create a photo panoramic view. This is a very old application that was done totally in QuickTime, but I thought it was kind of evocative and interesting of the kind of applications that I think we're in store for in the future here. So we're seeing things like this now in Second Life. This is a pretty famous incident in Second Life. IBM engineers created a complete model of the Forbidden City, you know, this giant architectural treasure in downtown Beijing. And Sam Palmasario, the CEO of IBM, gave a presentation in Second Life from the Forbidden City. Now, this is all cool, but there's something really disconcerting about this to me. The Forbidden City doesn't exist coherently in Second Life. It's just kind of dropped in to an incoherent geography. The geography of Second Life is totally incoherent. It's just random. Islands here, continent city there. The Forbidden City exists in Beijing. And so I think for a lot of applications, the idea of real places ought to exist in a real world model. Now, it's not to say you can't do things like have avatars or virtual interactions, but the idea of enjoying some of the social networking capabilities and experimentation that we've been experimenting the last couple of years in applications like Second Life can be improved for some cases, not for all cases, by building a realistic cartographic framework for them. So we're seeing a lot of parallel software development efforts to build code to build these kinds of environments. CityGML is a project that's part of the Open Geospatial Consortium. And GML is the geographic markup language. It's an XML language, and it is, quote, a standard in the geospatial community. And important web standards like Web Feature Server, Web Map Server, and others are built on GML semantics. So this is new. This picture is a picture of virtual Guadalajara, which was a demonstration for CityGML. And then we have other efforts like X3D. And X3D is a development built on the VRML family of code. And so we're seeing a lot of progress. It's a very active community. And Rita Trukowski's here. And Rita, can you raise your hand? Anyone who's interested in one of the leading efforts to develop interoperability in 3D is Rita. So Rita's working with the OGC and working with all the SIGGRAPH communities and trying to find ways so we can begin to develop model-based computing for three-dimensional environments. But we're seeing, as I mentioned, a shift in sort of the entire applications model. On the left, we see 3D buildings that were created in some CAD program. And there are lots of different CAD programs. But we're seeing now that people are not just building these 3D models on consoles, but people are starting to look through the viewfinders of their phones. Now, in this particular example, this is a photograph I clipped out of the MIT Tech Review. Some of you may have seen that last month. This is called handheld augmented reality. And there's a Nokia project, but there's many other projects. In order to hang a hyperlink on the real world, to put a 3D GeoRSS or KML annotation, you need to have an implicit 3D model. It can't be just a flat model. And by the way, that's one of the issues with Google Street View is there's some dissonance with that flat photographic plane when you know behind it's 3D. And so in order to have a truly effective 3D GeoWeb for augmented reality, we're going to need to be processing these 3D models somewhere, even if we don't render them all the time. So we're seeing now the dawn of mobile augmented reality, and so we're going to see devices that have not only an accelerometer like your Mac or your iPhone, and those are done principally to preserve the hard disk, but you're going to have things that have GPS and maybe some range sensing capability as well, and an electronic compass. The good news is that people understand these applications. The bad news is that there's a company in San Francisco called GeoVector that's patented this kind of application upside down and sideways. And so we'll see how it works out. So far, they've been enabling this kind of point and click on 3D hyper annotations only to very closed walled garden applications operated by their clients in Japan. So there's an issue there. The other issue is that to do true augmented reality, you need to solve some really knotty parallax problems. Remember that GPS and other popular location sensing programs like Wi-Fi geolocation only give you about 20-meter accuracy. So being plus or minus 20 meters, it doesn't give you the ability to get a very accurate positioning of a link on the world. So you've got to solve that parallax view problem. So I think that there's going to have to be embedded sensors and fine-grain sensor fusion and for the fine-grained positioning that we really need for this augmented reality. But it's going to happen in a lot of different ways. One model for augmented reality is that we don't need position sensors at all, and that we're going to use RFID tags on products or maybe even the barcodes on products. This is a photograph of a project that was developed by a guy named Mark Smith at Microsoft. It's called Project Aura. And Mark has hacked his phone and put a better lens on the phone so he can actually get a good rendition of a barcode. So he snaps a picture of a barcode, sends it to a search engine, does a pattern match, a lookup, and can send back information. It's curious, with the exception of a few Nokia phones, most mobile phones, even though they have high resolution sensors, you know, some phones are sold with like 2 megabit sensors and you know, other big CCD arrays, the lenses are terrible. And the lenses won't give you that resolution. Nokia has published, or has released a few phones that have got better lenses. But what we'll be able to do once we have these phones or these mobile devices is enjoy a new kind of mobile commerce. You'll be able to walk into a store and see a media wrapper around a physical object. It's not just the printed artwork on the box. There can be a whole animated graphic showing you whatever the manufacturer wants you to see. But the real fun is you're not limited to looking at just what the manufacturer wants you to see. You can pull up competitive information. You can pull up the lab test on the harmful ingredients. You can find out that it was made in a sweatshop. You can find out that it's for sale at half the price across the street. And so this is going to disrupt commerce. So what we'll need, though, to have a seamless blending of real world and virtual worlds is for these 3D models to give us the same kind of virtual shopping experience in virtual worlds. And so if you are a retailer, you might want your retail environment to exist not only in the real world and not only provide augmented reality, but if you're going to produce the data, you only want to produce it once. And so you want people in virtual worlds to be able to use that. And so a lot of interior information is typically stored in CAD programs. And so of all the other kind of interoperability that's required between games and social worlds and geographic renderings for scientific visualization, we've also got to find ways to introduce 3D CAD. And this is a particular interest to the Department of Homeland Security right now. After 9/11, they found out they really didn't have good interior maps of a lot of buildings. So they're spending tons of money to develop 3D GIS systems. And so ideally, the same kind of 3D GIS that people will be building on Homeland Security grants will eventually migrate out, and we'll be able to use those for all kinds of interesting applications. So we're seeing new kinds of blends of real world and virtual worlds. There's a group up in San Francisco, Planet 9 Studios, has been building these city models for a lot of defense and intelligence communities. And so they have a rather rich set of models, city models, and so they've kind of launched a beta version of a game called Raygun. And here you see the Raygun game being played in downtown San Francisco. And I took a spin around San Francisco in the Raygun environment. And it's cool, but you get to the Bay and all of a sudden you're just looking out in this gray wasteland. They have San Francisco, but they don't have Oakland. So it's the same problem as the Forbidden City in Beijing. You know, there is no Beijing, and here there's no Northern California, just San Francisco. But it's interesting, and I think they're building a mobile version too. So you might be able to play this social game in real time, real place in San Francisco. So we're seeing other real world virtual worlds. Some of you may have heard about Sun's experiments in building virtual worlds. They've got an experiment called MPK20, which is a virtual Menlo Park. And so this is a collaboration space for Sun employees, and it's a model of a real building in Menlo Park. It's one of the Sun buildings. And they've got a lot of rhetoric on why this is a good idea, and you can read it at one of the Sun websites. And so we're seeing another company here in the Silicon Valley called ForTara that's building these virtual worlds, but they're building them strictly for industrial applications. They're building them for emergency response, for medicine, for factory production. And so here we see, it looks to me like an emergency response scenario that exists maybe in a real city or an imaginary city, I can't tell. But one would hope that, for example, these avatars here don't have to be created from scratch, and that we might be able to somehow port an avatar that was created in another environment like Second Life. So interoperability in these worlds is going to be an increasingly important issue. Remember that we didn't really enjoy the benefits of the internet until the development of HTML, which was a document standard that allowed you to view a document through any kind of application. And so we need the equivalent of a 3D data model to really enjoy the benefits of a 3D web. So we're seeing now some really interesting blends. There's experiments now in various labs around the world. In the upper left is one that brings a emergency room intensive care to a patient's home. And the virtuality of this is kind of interesting because the instrumentation is not fake. There's some, I just counted, there's some 30 different kinds of mobile sensors that have been released for wearable devices and for home appliances. And there's all kinds of really interesting and useful medical therapeutic devices that can communicate with an implanted processor in your heart or other wearable devices. So we're going to move very quickly in virtual medicine from health monitoring to health coaching to remote treatment. Here is an experiment, I think this is at Fraunhofer Labs in Germany, of a video conference that is not really a video conference, it's a virtual world conference where the person in the foreground is real, but the person in the background is just a 3D rendering of a person. So we're seeing also now a lot of dramatic new thinking in the world of video games. This is a mock-up of a game idea from a Nokia-sponsored research program at Oulu in Finland. Just think, if you can drape real information across the physical world, there's no reason why you can't drape imaginary information. So this room right now may be a conference room in Wallenberg Hall, but with a click of a mouse or a flip of a switch, I could convert this room into a meeting room on a Starship Enterprise. Or right outside the walls out here in the quad of Stanford, we could have a medieval tournament going on. You can drape total fantasy, total fiction, total imaginary reality on the physical world. And so this only gives us a hint of the kinds of things that people are developing. So this, as I mentioned, is just kind of a sampler of some of the ideas that I've been working on, and there's a lot more that we have investigated and we'll be investigating. So I'm ready to answer questions or take your complaints or whatever you want, or turn the podium over. Hi, Hugh. Any questions? Any comments?
Excuse me, I'm the microphone monkey, so please wait for me. Yes, please tell me what your name is and where you're from as well.
My name's Kerry Carlisle from BP. It's a great talk, and I think it summarizes a really important trend that we're seeing. A couple of comments, because I think all of these areas we've been looking at are really fascinating areas. One is, you mentioned the OGC, the Open Geospatial Consortium.
Yes.
My understanding is that some of their new standards actually start to integrate CAD and building information into the the real-world model. So we are actually getting towards this unified 3D model, or at least one version of it.
Well, except that the OGC and the W3C barely talk to each other, and everybody in the entire world of 3D rendering and 3D model building in CAD and all of the virtual world and gaming communities are not part of the OGC processes. So yes, in the geospatial community, they're lurching towards some consensus, but meanwhile, their kids are in the other room playing with different 3D worlds.
Fair enough.
So, it's not clear whether it's a benefit or not if certain communities standardize at this point, or whether it will be more beneficial for all the interested parties to gather together and hammer out larger interoperability. But meanwhile, I can tell you that while there is division between the worlds of geospatial standards, the worlds of scene rendering in Hollywood, the video game worlds, CAD, Google will prosper. And Google is creating de facto 3D standards around KML and Collada that we're probably all going to have to live with.
So that's all very true. The other comment was just a passing comment about GPS. You mentioned 20-meter accuracy.
Yeah.
You can actually get 2-meter accuracy today with a handheld GPS with EGNOS and WAAS. And I was talking.
But not in all environments.
Not in all environments, no. But if you use real-time kinematic GPS, you can get down to 1 centimeter if you have an augmented network. So we're getting there, and when Galileo comes out, I think we're going to see better accuracy, especially in some of the more constrained environments. So we may get some of this stuff without the need to have sensors around the environment.
Well, you mentioned differential GPS. That is, in fact, sensors in the environment. Those are GPS, augmented GPS base stations. And so to get the kind of millimeter accuracy, or what RTK, real-time kinetic accuracy, that a lot of applications, particularly augmented reality, would like, we're going to have to, I think, put some signaling base stations. And you can also, to get the kind of accuracy you want, you don't have to use just GPS. So we're seeing people who are experimenting using Wi-Fi signaling, Bluetooth signaling, infrared, and LiDAR to give a combined fused view of a position. And so I suspect, I think that the idea of Galileo as a compatible signaling system as part of the GNSS model is brilliant, but if the Europeans could just get along with each other and build the darn system, we can look forward to a day. I do know that some of the vendors and designers of GPS chips are already looking at the abstract specifications of dual receivers for US GPS and for Galileo, and we can all hope for it, but it's,
There is actually a valley in Switzerland where they have test transmitters, and you can test Galileo kit, but that's another story. Anyway, thank you very much.
Thank you for your questions. We'll take one from Second Life right now, and then I'll get back to you. So, we actually Flim-Flam asked from Second Life, what year does Mike think that Gerlentina's mirror world dream, full convergence between virtual and actual realms, will come to pass? Big question, Mike.
It will be March 13th, 2011. At noon.
And you heard it here.
No. Well, nobody could predict the future. There's too many variables.
It is hard to predict, especially the future, isn't it? So, yes, please say your name and where you're from. Thank you.
Hi, I'm Frank Kühnel from NASA Ames. And
yes.
Actually, my question is more pertaining not to the visualization, but you know that the internet is so successful because people can copy and paste and text and images. It's so easy now to basically just copy and paste.
Yeah.
How do you envisage that basically going on, creating worlds like copy and paste in 3D? Because you probably rely on a lot of people to create content, and it needs to be free and without copyright infringements and all the other things. What is your view to the future there?
That's a huge topic. It's both a technical topic and a topic related to the problems of intellectual property. So on the technical side, I think it's going to take just an enormous amount of computing cycles and some very, very clever programs to do the format conversion to copy and paste from one domain to the other. I mean, that's kind of one of those computing grails that we all have to work on. It's a very, very difficult problem. Assuming they were all in a standard data format, for example, Collada's 3D format, I don't think there's any reason why you won't be able to copy shapes in a Google KML style environment. But if you try and copy something from Google Earth and paste it on Whirlwind or paste it into a virtual world like Second Life, there are the issues of the format conversion. So I guess those are just enormous technical difficulties. It's going to take us a long time to sort through.
Okay, we'll take another virtual question.
Sure.
I guess they're all virtual here tonight. So this is from Tara 50, which is actually Tish from New York, one of my friends. She asks you, how can the kinds of data visualization and aggregate statistical information about the world that are frequently only available to big companies and used by them in order to realize profit and control also be put into the hands of individuals?
Well, there's a couple of interesting things. I mean, first off, data visualization is kind of lurching it into the public domain. For example, police crime maps are increasingly available. So you can visit a place and find out what the incidence of crimes are at a particular corner. You could find out places that may or may not be safe to park your car. We have projects like I think it's called the SensorWeb project at Microsoft, where they've got networks of all kinds of environmental sensors out there available freely in GeoRSS format on Microsoft Virtual Earth. So some of in fact, the SensorWeb architecture at Microsoft is, in fact, since it's built on common standards, will work with a variety of sensors. And we're also seeing a lot of sensor data that's collected by life scientists and physical scientists available. So a lot of biological information and weather information is going to come online. There are efforts, there are citizen sensing projects. Eric Paulos over at Intel Labs in Berkeley has been doing all kinds of things by using mobile phones as sensors. There's a group at UCLA called CENS, Center for Embedded Network Sensing, that has got a whole project to allow citizen sensing. And Nokia has a project called SenseWeb, I think, and they've got sponsored research programs at about 10 universities worldwide to come up with interoperable standards and mechanisms for ordinary people to create and share three-dimensional sensor information and to visualize it as well.
Excellent, thank you. I am testing the perils of augmented reality here because I thought the video stream had died there for a second, but we're good, so I'm jumping between worlds. Matt?
Hi, my name is Matt Roberts from Crystal Dynamics Games, and given that the existing web is largely successful because so much of it is opt-in, nobody establishes a web server or web page about you without your permission, generally, unless you're a celebrity or some sort of exceptional case. Do you anticipate some sort of legal challenges to identity and property and sort of personal opt-in to geospatial information? For example, in terms of any implications other than sort of the legal precedent set by things like journalism, where there is a definition of acceptable expectation of privacy and that kind of thing. Do you have any thoughts on that?
Yeah, I do. I mean, we've seen, for example, Google fuzzing pictures on demand by governments. They fuzz some defense installations in India on some of their satellite pictures, and I think they blurred Dick Cheney's house in Washington, D.C. So I mean, there are going to be things where privacy of spatial information will be enforced by government policy, but there's also issues of citizen privacy that are coming to the foreground rather quickly. There's an enormous amount of data. It's called it's got a funny word for tax data. Is there a geographer in the room can tell me what the funny word is for property boundaries? Cadastral. There you go. Cadastral data and tax information is actually being made available in some jurisdictions, and so you could actually view a file on a virtual Earth of the property boundaries of someone's property, and then you could take a look at a recent aerial photograph and say, oh, that shed wasn't there last year. It must be an illegal shed. And so there have been, in a number of jurisdictions, some citizen backlash against both the availability of cadastral data and of tax boundary information. So yeah, we're seeing the beginnings of that. And we saw also, you know, when Google first announced this Street View, you know, people were angry that there was a photograph of their cat in the window. So yeah, it's, you know, it's just one of those policy issues that we're going to have to work through over the next 10 years or so.
I started to think about it because it actually got captured. On Street View. It was really bizarre, and I felt kind of strange noticing it. I mean, I wasn't sure how I felt about it. I supported the project up until I saw that. I still support it, but it definitely was a different aspect on it personally.
Yeah, but you could have easily been photographed at a music concert, a baseball game, or, you know.
When a man's got to go, he's got to go. So another question from Second Life. Second Life has all of the elements to support artificial general intelligence, perception, effector, state model, autonomy, etc. Is the blurring of the lines between us and them, human and machine, the high noon of the metaverse? Second Life is also the furthest along regarding open sourcing of the 3D immersive worlds. But how do you see these characteristics that support AGI being integrated into the 3D geospatial web? Oh boy.
Well, let's, you know, let me, you know, blurring, let me just kind of, you know, I don't believe in high noon type crises. You know, there's a whole series of kind of phases that we go through. So let me just say, no, that there's no crisis between us and them, or virtual versus real renditions of human beings. But I need to read this to parse the question.
That's okay. Let's just move on.
Oh, well, let me just say
okay.
that AGI, I would dispute the fact that Second Life is the farthest along. I think that, quite frankly, I believe that any day now, Google is going to announce avatars for, and avatar-based social networks for Google Earth. And in fact, you know, the rumors are rampant. They've already tested it. And if that's the case, they're farther along. I mean, there are structural problems with the computer server architecture in Second Life that restrict the kinds of applications you can run. So I think Second Life is one of the greatest social experiments, but technically I think that they're going to be eclipsed.
Excellent.
Paul Byrne from Sunrock Systems. The Wonderland stuff from Sun's been open source, front to back, top to bottom since March. So I think we're ahead of open source.
He works at Sun, by the way.
Oh, great.
So
I hope I didn't mischaracterize your MPK-20.
Yeah, this is getting lively now. Here you go.
I have a question. Okay, Bart Menayas from Electronic Arts. I'm asking this week about robots and Rayman. This week about robots and Raymanta and experiments where very small robots, flying robots, can take pictures and be automated. They're currently used in the military, but they would become cheaper and cheaper and more used by civilian purposes. So is there any plan, instead of having trucks going through streets, to have, you know, miniature flying machines taking pictures everywhere? Because according to that article, it was pretty much getting there right now.
Well, yeah, I mean, Larry Page and Sergey Brin can afford to fly airplanes wherever they want. But, you know, there's other approaches, by the way, to mapping. You know, there are people, Google, for example, that is concerned about sort of the monopolistic position that TeleAtlas and Navtech have. And so Google did something very interesting. I don't know if many people know this, that in September, Google undertook an effort to map sections of India using crowdsourcing techniques. They passed out scads of GPS devices to ordinary citizens and had people go out and start capturing track logs. And just the way, for example, the Mechanical Turk helped people process photographs of Jim Gray's disappearance. So it's the idea of crowdsourcing large problems. So OpenStreetMap in London, for example, has been using all volunteers to create spatial information. Lots of people using a variety of different devices have been creating very accurate renditions of London. They've been forced to do that because the British policy, the Ordnance Survey in the UK has, for their own cost recover and profit motives, as a copyright that they enforce on the boundaries and the the road diagrams for the UK. And so the open source community has chosen to create their own maps. And so I think we're going to see a lot of bottom-up grassroots mapping techniques using any kind of gadgets that people can get a hold of. We had something called Where Camp last spring, and there was a guy there who had a LiDAR device. And so hackers are going to have 3D data gathering tools. And yeah, some of them will put them up on robotic aircraft. I can see it. Maybe a couple of years, but yeah.
Excuse me. We'll take one from the avatars right now. I actually a few years back moved here, and I tried my first big earthquake pretty recently, and I don't know if you guys would call it big, but the next question actually been on my mind as well. So what happens when there's an earthquake and the cell service is down and ambulances can't find their way around? Like, in other words, we get so dependent on this technology that augments our existing capabilities so much that we forget how to make fire. What happens then, Mike?
Well, this, of course, is a concern that arose immediately after the Indonesian tsunami, and there were lots of questions like this after both Katrina and the 9/11 attack. So there are a lot of people in the emergency response communities that are working on very, very quickly deployable wireless networks that will give positioning capabilities as well. I, for one, have my own KU band satellite dish, and so I get access to the internet, and if my whole community goes down, I'll still be up. Of course, unless the earthquake tilts the dish, and then I'll...
That's true.
You might want to mention...
One second, please.
You might want to mention, Mike, that the OGC has an emergency response program standards workshop that they've just started a few months ago in their Boulder meeting, so they're addressing that as well. In fact, can I... Sure. And I have a question for you. Sorry, I'm Rita Turkowski from Web3D. What's your take on all the good work going on now with CityGML and GeoRSS, which is a big part of the OGC, and how they're working with some of the open source Earth groups, and what impact that might have on virtual world building? Because they seem more structured and more organized to me in their efforts than some of the random virtual world efforts that are going on right now.
Well, they're not connected. GeoRSS is a totally grassroots effort that a couple of guys at OGC have embraced and said, we like it.
Yes,
and they've written some memos saying we support it.
Not a formal standard, but I was just at one of their meetings and we had a joint meeting with them last week, and it certainly was brought up, and it's a big part of where they're moving. Actually, it's a small part. It's actually not very much work to incorporate the code.
It's the 2D. Yeah, so yeah, OGC, I think was already mentioned over here. OGC is working on a lot of 3D standards. But I think aside from your visit with them, I don't think there's anybody from the world of scene simulation or virtual worlds or 3D graphics has spent much time with them. So, yeah, so we need a lot more dialogues like that, and it's really great that you're here too and can kind of draw on some of the folks from the virtual world community to talk with you as well.
Come up that the CAD people will probably join both groups, or certainly OGC. They have an interest, and they basically export to Collada anyway, so getting the three of them together is nice.
I just want to mention that the entire community that created GeoRSS has gone along and created another good geo standard. They created something called GeoJSON, which is a real nice, lightweight, client-side scripting language that doesn't have all the bulk and heaviness of XML that allows cross-site scripting. And so there's now, and anybody's interested, see me afterwards and I can talk to you about it. It's really cool for nice, light, client, browser-based geospatial information. But again, no 3D.
Okay, we have a question over here. I just wanted to say to people in Second Life, like, my apologies that they're here on a like bleeding edge technology experiment, and that can be a bumpy ride sometimes. So I understand that sometimes the questions have been a little choppy for you guys in there. We are recording everything here, and we will post it freely available on the web, and I'll make sure you get that URL.
I'm sorry, Christopher Phillip. I'm working with the American Indian Higher Education Council, and I work with Reality Digital out of Burbank. Your statement that the Aspen movie map took 20 years before we could actually enjoy its benefits was very interesting. The Department of Commerce has said that geospatial technology is a dramatically underserved educational pipeline. It's really important. Hardly anybody knows what to do about training and educating people on it. So the question is, out of all the fantastic things you've shown us that are being done by think tanks and corporations and government agencies, could you suggest where this is actually being applied to the community college and college levels as actual tools for learning, please? Thank you.
Sure. There's, first off, ESRI, Environmental Systems Research Incorporated, which is the largest old-style mapping company, has lots and lots of outreach programs, and there's schools of geography and schools of cartography in many, many community colleges. But for the underserved communities that you described, for example, the Native Americans and other communities, there are a couple of really, really cool projects. There's a group called PPGIS, which is Participatory GIS, and there's a distribution list of people who are working all over the world. There's NGOs, non-governmental organizations, who are working with people in Africa, Latin America, Asia, to enable grassroots mapping and citizen use of spatial technologies for social benefits. So it's quite a robust community. I'd be happy to connect you up with those folks. There's also a group of Aboriginals and Native Americans that have been meeting irregularly, and they had a big conference on mapping for Aboriginal communities in British Columbia last year too. So I'd be happy to introduce you to those communities as well.
Thank you.
Actually, also in the name of like having an ongoing discussion about this, I set up a Metaverse Meetup group in Google that can also be a discussion forum, and that I intend to make future announcements around this on. I'll put it on the Facebook page that some of you guys saw, and when I invite to the next one, 3 weeks into the future, our next Metaverse Meetup, I will announce a Google group as well, because maybe some of these discussions can live on. Any other questions? I think the people in Second Life is probably suffering so badly that the lag is there. There seems to be a build-up. It runs and it streams pretty well, but then it kind of bloats up, and it's a little hard to reboot in the middle of when Mike is answering questions. So they seem to be struggling a little bit. Did we have any other questions at this point? I talked about an open mic as well, which is a totally sort of free for all. If someone wants to get up, like for a minute's time, and just kind of give a shout out. And I actually was. Do you mind if we just like open it to the floor?
Please, it's your meeting.
Feel very free to jump in at any point. Can I out you, Paul? You work at Project Wonderland over at Sun. Maybe you can get up here and tell a little bit about what Sun is trying to do in the metaverse.
Thanks. So yeah, I'm Paul Byrne from Sunrock Systems. So I'm the project lead on Wonderland, which is the underpinnings of the MPQ20 demo. So the focus and the reason we're sort of in this space is Sun has a very distributed workforce, and we've had a scheme called iWork going for years, encouraging people to work flexibly and remotely. And the result of that is over half our employees are not on a Sun site at any given time. They're on customer sites, they're working from home, it's completely distributed. Then on top of that, you have the problem that we're a global company, so we've got teams that are distributed across China, Prague, the US, trying to work together. So the problem we're looking at solving was, well, how do you get those people to have the same experience as you have with co-located people? How do you do the coffee maker conversations, the hallway conversations, the post-meeting conversations? We have video conferencing, we have telephone conferencing. They're great for, well, great maybe a bit of a strong term, but they're okay for sort of the meeting. But how do you do the innovative bit afterwards? If you have a meeting like this, when we break up, there'll be a ton of conversations in the corridor, and people will move between those conversations, and it'll be very fluid and dynamic. So we were thinking, well, we started this project in January, and that was when Second Life was its big media blitz, and the thought was, well, it seems like a virtual world could add a lot of the social aspects back into the collaborative environment. So what we did was design an infrastructure that sort of adds three key features really. One is security. In a business concept or a technical meeting, you don't want flying pigs or porn in your room. That's not appropriate. So we have a security system, which means we can enforce what content gets delivered to the clients. The second one is, well, how do you communicate? The obvious one was, well, you talk to people. So we integrated a CD quality audio system into the world with distance attenuation. What that means is as you approach, speaking people, they get loud, and as you walk away, they get quieter. That has proved to be enormously powerful, because what happens, we're having our meetings in world now. So what happens, you have your meeting, everyone's standing in a crowd, you can hear it. But then you drift apart at the end of the meeting. And you can have these isolated conversations. And there's no setup. You just walk between groups of people and have conversations. It's very natural, very fluid, very dynamic. And the last piece was, well, okay, we want people to collaborate and work together. Well, what they're going to work on. And the thought there was, well, let's give them their desktop tools that they use every day. So we can run any desktop tool in the virtual world and have people collaborate together on the desktop tools, both X11 and Windows applications as well. So the focus is really on trying to build an environment where people work together. And work doesn't mean just in a business environment. You know, you can do it in a social environment too, sharing photographs. We've just put a world together for a sort of a shared musical experience. So you're inside this huge set of albums, and as a group you can select albums and sort of plot paths through the music and stuff. So we'll try and explore some other spaces too. As I mentioned earlier, the system's been open source since, I think, March we open sourced it. So the whole thing is open source, it's all GPL. The art's all open source as well, because that's a path we're very interested in making sure that stays open. We don't want to lock content into the world. And we're busy trying to get the system stabilized and the first release out, and then start scaling the system. Thanks.
Thank you so much, Paul. I think you spotted an interesting question from Second Life. Maybe you want to read it out and answer it. Is that okay?
Yeah, someone named Kat Limu asked a question about when will we see the first examples of blended reality, augmented reality, and AI. And there are two really great examples. First off, the military. The military is already blended reality, augmented reality, and AI in really amazing battlefield simulations down at places like Fort Irwin. The other non-military place where we'll probably see the first examples are in video games. In fact, just this week there was a new video game released for the Sony PlayStation called, I think it's Eye of Justice, or any gamers here? Eye of something or other, that allows you to take a game card, like a Dungeons and Dragons card, put it in front of the camera, and the camera will show the 3D graphics augmented over a real video view. So Sony is already experimenting with an augmented reality game. So if anybody's interested, see me later, and I can dig out the URL. I was just looking at it last night. So I think that very early on, I think we're going to see video games.
Can you just speak out your email address as well for the benefit of people in Second Life? MLIEBHOLD@IFTF.org. Or just Google him. You'll find him.
Whatever.
Any other questions? Maybe it's a good time to start thinking about rounding off. And I have to take my little cheat sheet out. And thank you, Mike. Can we give him a round of applause, please? Yeah, that was very compelling. Thank you so much. So, Galen up there has been faithfully video recording everything, and hopefully the people in Second Life can go back and see what they actually saw. And so we're going to try and put it out there for everyone, freely available. And I've set up a Google group called Metaverse Meetup, and that's freely available. Everyone can write to it and stuff. We'll see how it behaves, and then we'll just take it from there. But that's a good place to look for future announcements, to get to continue discussions that happen here. And part of the thought around this was really trying to get some kind of cohesion, like in the metaverse sort of community in the Bay Area. I've been looking at the web community for a long time and just seeing how incredibly well they did. And maybe it's because we have these compelling, immersive virtual worlds to meet in that we have less desire to meet out here. I don't know. Let me just plug the Metaverse U conference again, February 16th and 17th, right here on the Stanford campus. Watch out for some announcements around that. And then, if I got too burnt by the first one, then I better set up a few right away. So actually, in 3 weeks from now, we're going to have Jamay, actually one of Mike's colleagues from the Institute for the Future. He was one of the authors of a very interesting document that came out this year called the Metaverse Roadmap. that basically outlines a suggested, kind of a suggestion for like a taxonomy of where these spaces are going, and definitely also is trying to open it up to wider discussion, much like, and I know that Mike was involved in this roadmap as well. So he's coming in 3 weeks, so please mark your calendar. I believe that's the 29th of November, and I want to thank you all for coming. Thank you so much. It's been a real joy, and I'm really glad we pretty much filled every chair in here. And you don't have to sort of get right out. It's definitely time to hang around and socialize for a little bit. Thank you so much.